This is the Building Automation Monthly Podcast with Phil Zito, episode 83. Hey folks, Phil Zito here, and welcome to episode 83 of the Building Automation Monthly Podcast. And in this episode, I am going to be talking through IP controls. Specifically, I'm going to be teaching you the 7 things that your customer, whether that is your boss or your actual customer, wants to know about IP controls. So IP controls are all the rage right now. They are something that the industry is starting to embrace, and you're seeing more and more IP-enabled controls being installed on jobs and being flat spec'd, meaning this is the only essentially control architecture, control system that you can provide. You're seeing this on some VA jobs, you're seeing this on some college campus projects where their specification, their design standards are designed around IP controls. But when I started thinking about this, I was like, why is that? What benefit do IP controls really have? I've played around with IP controls in our test lab, and I've been involved in a lot of IT systems which support the IP protocol, the Internet Protocol. And at the end of the day, I'm still just not fully sold as to what the value prop is, or at least I wasn't fully sold. So what I did was I went and reached out to several different folks. I reached out to multiple different vendors and their IP controls specialists, and I talked to them. I talked to some specifying engineers, and I talked to several customers who are utilizing or considering utilizing IP-enabled controls. And what comes from all of that is this episode where I talk about the 7 things that you really need to know around IP-enabled controls. So let's dive in. All right, the first thing is, what are IP-enabled controls? I mean, I've got some degrees in IT and some certifications in IT, and at times I can just assume that everyone even knows that it's common what IP is. But the reality is that there's a lot of people who don't know what IP is. Just like there's some things I don't know about, in-depth things that a mechanic would know. Well, let's start there. So IP-enabled controls are simply controls that support the Internet Protocol. And when we're talking about IP-enabled controls, what we're usually talking about is BACnet IP. Because if controls simply spoke IP, but they had no other protocols that they supported, there'd be ways to consume the data, but it'd be very difficult. So it's kind of misnomer when you say IP-enabled controls, because the majority of IP-enabled controls are really BACnet IP-enabled controls. And in that case, they're mainly replacing the old BACnet MSTP protocol, which was the field bus protocol that a lot of controllers would use. Now, I say the old BACnet MSTP protocol, but it's really not even an old protocol. It's still in use today. It's just something that, for whatever reason, folks associate MSTP as old and they associate IP as new, even though both protocols have been around for several decades now, so neither one is truly new or old. It's just a different architecture. So here's the thing, though. When folks think about IP-enabled controls, they picture Ethernet. They picture RJ45 heads on some Cat5 or Cat6 cable, and that's a type of Ethernet cable. But IP is not Ethernet. IP is not the 802.3 standard. That's the Ethernet standard, by the way. IP is simply a protocol that exists at layer 4 of the OSI model. The standard that you use, whether that be Wi-Fi or fiber or Ethernet, that is independent of IP. IP rides on all 3 of those frameworks. Actually, IP can ride on several other things. You could have IP over multiple different protocol types like cellular communications or over Zigbee, things like that. So that's the first thing you got to get out of your mind is you got to break this association with IP and cable type. Now, from there, we go into our second thing, which is number 2. How are IP controls different than MSTP? Well, here's the deal. First off, IP-enabled controls, they exist at that TCP IP layer, and they exist at that network layer of the OSI model. So that's layer 3 and layer 4. And if you're not familiar with the OSI model, I'm not going to cover it in this episode. I've discussed it in past episodes, but I will provide a link in the show notes to an article I've wrote on the OSI model, and you'll be able to read that. Now, here's the deal, though, with IP-enabled controls. What you want to realize when you're talking about MSTP is a daisy-chained architecture that relies on MAC addresses and exists at layer 2. So first off, it's not going to be able to exchange between networks. It's what's called link local. It's local to that network. Versus IP, which IP can stretch across multiple different networks using things like routing and all sorts of other stuff. Now that introduces a whole slew of concepts like BBMDs and routes and VLANs and IP subnets. But the important thing about MSTP is completely different than all of that. And that introduces some really interesting design I want to say constraints, but I'll just say design considerations. Because when you're thinking about designing an IP network, what you need to consider is the IP addresses. What subnet are they on? How are they going to route to other subnets if they need to? How are they going to be on other VLANs? Do you have duplicate addresses? Versus with MSTP, you can have on several different field buses, you can have controllers that are MAC address 40, MAC address 40, MAC address 40. And you can have that again and again and again because each field bus is isolated from the other field buses. What happens is those field buses come into a supervisory device and then they are routed to another network. So they're essentially normalized at the supervisory device. So that is the big difference between IP and MSTP. And also MSTP tends to support serial communications versus IP, which is non-serial communications. And serial means all the data just comes in series, whereas IP is actually you're able to send IP packets that some packets get there before the other packets. It's kind of weird when you start to think about it. But when you introduce routing, data is not sent in series, and it creates some interesting troubleshooting dynamics that we'll cover in a later episode when we go through how do you troubleshoot IP networks, how do you design IP networks. We'll have later episodes that dive deeper into that because, as you can imagine, this is kind of a 30,000-foot flyby. Now, when I started to think about this whole IP control scenario, I started to ask myself, what are the use cases where you would want to actually use IP controls? Why would you want to go and use IP controls? Well, first I thought, well, what if you have an existing building? And this was my first use case, an existing building with IP infrastructure. Now, naturally, when I say IP infrastructure, my mind goes to switches and Ethernet jacks on the wall. However, an IP infrastructure can also be a wireless infrastructure. So when you start to think of things from that perspective, a wireless infrastructure or a 4G infrastructure where you're using IP addressing, but you're not dependent on wired networks, you can see why this would be actually quite valuable in existing buildings. However, not every manufacturer supports wireless IP. And the jury's still on the fence as to if folks are going to feel comfortable with wireless. There's this conceived notion that wireless is less secure than wired architectures, which when you start to understand wireless encryption like WPA2 with pre-shared keys, you start to realize that wireless is actually pretty darn secure, and wired is actually pretty easy to break if you're not implementing all the different securities, which quite often a lot of people at the access layer, or the edge as we like to call it in the BAS world, the edge layer of things, they're not implementing all the possible security things that could be put in place to keep those Ethernet devices, those physical IP devices, physical when I'm talking about from a wiring perspective, secure. So, existing building with IP infrastructure, you could go and tap off of wireless. You could potentially even tap off of switches. Next, I had long run installations. So you got something out in a parking lot or something. Well, what you could do is you could run some fiber cable to that device. So fiber from one end to the other, and you can actually have mile long runs. You can have multi-mile run longs with fiber. And that then can give you this capability to do long run installations, and then you can use IP addressing. Now, granted, you could do 5,000 feet with an MSTP cable, but beyond that, you start to have signal degradation and you have to use repeaters and things like that. Whereas you could just run some single mode fiber and you could have a long run installation. And high bandwidth scenarios. Now, this is one I was kind of on the fence about. In the future, there's the possibility, like what some controls companies are doing, putting compute and putting analytic data processing in edge devices and kind of using what's called the fog instead of the cloud. Fog is essentially where you do compute in the edge versus cloud is compute in the cloud. So do you compute on a bunch of edge devices, or do you compute on a essentially cloud data center and then have the edge devices be a little dumber? That's kind of the decision folks are wrestling between from an architecture perspective. So you've got that going on, right? So high bandwidth scenarios, I can see where you use high bandwidth. I can see where it becomes important. It's not really that important right now, but it is important. Now, there's some other benefits that we'll cover later, but those are the main three use cases that I identified as I was starting to do research around things. Now, that brings us to number 4, the fourth thing that you want to know. And this is a question I myself had. Don't IP-enabled controls cost more? So let's explore this for a little bit real quick. So traditional BAS control install is going to look something like this. You're going to have a supervisory device, maybe for those of you in the Tritium world, that'd be a Jace. For those of you in the Johnson world, that may be like an NAE, and the list goes on, right? But you have a supervisory device, and that essentially reconciles all the field controllers from the field trunk. And from that field trunk, you would run daisy chain to each controller, the field communication bus, and you would run the power. And then you would have field controllers, and each field controller would have input-output modules. That's essentially the architecture you're looking at, right? And you've got cost to install, cost to run trunk, cost to run power, but you really don't need a bunch of switches. You don't need IP support. You don't need to have Ethernet cabling, all of that fun stuff. On the flip side, you have IP-enabled BAS controls, and it has a lot more variables. So when people say, does it cost more? It really depends, right? So on the high end of cost, you have star pattern PoE. And what do I mean by star pattern? Well, you would have a physical switch, and you would run Ethernet cables, Cat5e, Cat6, you would run that from each switch port to each individual controller. That's a star pattern. So it starts off at the single point and then kind of stars out these what are called end runs, single runs. And you would power the controller and have communication off that wire. Now the thing here is the switch is going to cost a lot more, thousands of dollars more, and you're going to have a lot of Ethernet cabling. Then you have another design pattern, which is called the daisy chain. Now, you can go from device to device on daisy chain, and that's good. The problem is that's a single point of failure. If that daisy chain gets broke at any point in that run, you're going to lose communication to the downstream devices. And then next up, you have the star pattern. These are all the physical patterns right now. And the star pattern, oh, wait, never mind. I already discussed the star pattern. The ring pattern. There we go. Alrighty. I'm not going to be editing this episode because I'm just getting back from vacation. I'm trying to fit this in this week. So, as I was saying, we've already covered the star. We've already covered the daisy chain. Let's cover the ring pattern. The ring pattern is where you'd start one run and then you do a full loop and loop back to the switch. So you'd have two ports that you would connect to. And the theory here is that if either side gets broken, it'll just run the other route. So that's all your physical constraint, or your physical architectures. Then you have your wireless architectures. Your wireless architectures, Zigbee, Wi-Fi, cellular, and these architectures support IP. And physically, there's a lot less pieces, but from a logistics perspective, from a technical aptitude perspective, it's much more difficult because you have to configure SSIDs, you have to do channel management, you have to make sure you have enough bandwidth in the channel, you have to do bandwidth allocation, which is very similar to quality of service, all sorts of fun stuff. So you've got to be aware of those kind of things when you're working with wireless designs. Which brings us to, what are the pros of IP-enabled controls? Why would you want to do IP-enabled controls? What benefits do they really bring to you? Well, there's a couple benefits. First, most obvious benefit is speed. Now, this is a benefit that I'm not completely sold on, to be honest, because if you do your MSTP design properly, you'll have more than enough speed for all the data that's flowing across the network. However, I have heard from a lot of folks that the configuration tools are a lot faster, the messaging is a lot more reliable, and there's just not really ever any slowdown on the network when using IP controls. That's great, but I've never really had problems with the MSTP trunks I've designed because I've followed design standards like addressing sequentially, 2, 3, 4, 5, so that the token doesn't have to search all over the place for the next field controller, going and maintaining proper wire discipline, proper shield discipline, all those kind of things. But let's say that you don't do that, or maybe you're not that good, then you would see a noticeable increase from IP controls. Also, if we ever do fully support edge compute, the industry goes that route, then you'll definitely want that speed. Now, there's the quote-unquote benefit of a flat architecture, meaning that everything's IP, everything can now be monitored by IP management devices. While that's good, that will also be in the cons section, which we'll talk about in just a little bit. But it is positive in that everything's on the same playing field right now, everything's on IP. There is this misnomer that, hey, everything's on the IP protocol, so we're all speaking the same protocols, but we're really not, because we have an overlay protocol of BACnet IP that overlays at the application layer. And so really what's going on there is you've got IP at the transport using UDP or TCP, and you've got IP at the network layer, but then you've got something like BACnet or Modbus overlaying it at the application layer. So while your servers may be speaking HTTP, your BAS controls are still speaking BACnet IP and BACnet at the application layer. So therein lies the rub. You don't really have a flat architecture across all layers of the OSI model. So I know that's a little deep, and that's probably a little further than some of you want me to go, but it's just an important point because a lot of people will tell you, oh, it's a flat architecture, but it's not really a flat architecture when you look at all the different things. Now, there definitely are more troubleshooting tools for IP, and there definitely is a greater maturity, at least when you get into the AV, IT, security world. Those folks tend to really understand IP troubleshooting tools like Wireshark, like SolarWinds for IP asset management, those kind of things. They really do have a lot more tools. The tool world is much more mature. I mean, it's kind of shocking to me that we have really one BAS scanning tool, and that's the one by Optico Networks. I'm probably saying that wrong. And it's a Visual BACnet, I believe, if I remember correctly. And I haven't reviewed that tool, so I can't recommend it or not. I haven't played with it. But that just kind of tells you the immaturity of our essentially network troubleshooting world of BAS, in that we just don't have a lot of tools for network troubleshooting. Whereas the IT world is about 30 years ahead of us. So you would expect that they would have a lot more maturity, right? Which brings us to 6. Kind of what are the cons? I really hope I'm not sounding terribly negative. It's kind of funny because I'm always the guy who's advocating advanced technologies and utilizing kind of strategies and ideas that I see outside of the BAS world. However, when folks talk to me about this IP enabled controls thing, I'm just, I'm kind of still on the fence. I'm leaning towards IP enabled controls. However, there are some cons that you need to be aware of it. The first is this is an unknown design process to a lot of folks. There are a ton of people who, when you say ring, daisy chain, star pattern, NAT, all those things, just those 4 things that I just said, and that's like just a tiny little bit. Variable sublength mask, subnetting, variable routes, dynamic routes, all those different things, those are unknown to a lot of BAS folks. Yet they want to design these IP networks. They want to go and deploy these IP controls, and they're not really prepared for all of these IT concepts, especially the networking concepts that you need to know in order to deploy IP-enabled controls. And therein lies the rub, because no one else is really teaching that. And this isn't a pitch, because I've already closed my IT course for the year, so you can't sign up for my IT course anymore. But there just isn't any IT training out there for BAS folks. Not anything that's made by BAS folks who understand the way we think, who understand what we need to know. It's just not there. I mean, really, think about it. How many other podcasts are there out there talking about this kind of stuff? Not to toot my own horn, but there's not a lot who are talking about these concepts out there. So, I mean, that's just the reality of the world we live in right now. That's kind of the fun of being an early adopter, yet it's also the curse of being an early adopter when it comes to technologies. Now, as far as cost goes, yeah, there are costs, but it really is architectural dependent. It's architecture dependent. It's linked to whether you're using wired or wireless and what form of wired you're using. That will determine your cost. That will also determine your IT involvement. Now, if you have never went and designed a subnet, if you have no idea what subnet masks are, you have no idea what network address translation is, you have no idea about any of these concepts, then you're really going to have to get sharp on these things really fast, because these are things you need to know. Now, I know there's a lot of vendors out there who are like, well, we've got tools that'll configure it for you. That's all well and good, and maybe you do, but the thing is, when stuff hits the fan and things don't work, who's going to support that? If you don't have this knowledge, how are you going to go and understand what's going on? How are you going to go into Wireshark and go through the different layers? How are you going to piece this apart? You really have to get those skills around IT. And normally that comes by working with the IT department. But that brings its whole nother set of problems, in that folks are having to get involved with IT, and everyone's always like, oh no, I don't want to involve IT. They're so difficult. They take so long, da 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 da. But the thing is now if you're going to do this, you really have to involve IT, which means you're going to have to know the questions you need to ask. You're going to have to know how many IP addresses you need. How do you identify that? How do you figure all of this stuff out? You're going to have all of that lined out before you ever walk in the door. And then, like I said, there's the troubleshooting piece. You get this installed, but you've got an IP conflict. Like I've heard some folks who are like, "Oh, that's fine. I don't need to involve IT. I'm just going to put DHCP on, or I'm just going to go and grab IP addresses based on whatever I see pop up. I'm like, really? You're just going to grab IP addresses? They're like, yeah. I'm like, well, what happens when you take down a server? What happens when you duplicate an IP address? And they're like, well, I'll get a warning. I'm like, really? Maybe you'll get a warning. Do your IP controls have graphical user interfaces that are going to pop up and give you a warning? I mean, you may be taking stuff offline that's critical to the business. So there's this whole slew of problems that can come from this. So it's just really important that you get tight on this. And I've written several articles that I'll link in the show notes, and I've done other podcast episodes that I'll also link in the show notes. And, you know, it's almost like a little mini course you could do. Try to bring yourself up to speed as best as you can. And finally, number 7. I feel like I'm so doom and gloom. I feel like I'm just being totally negative here and bashing this. I'm not telling you to avoid IP controls. I'm not telling you to avoid IT. If anything, I'm encouraging you to embrace IT, to embrace technology, because it's the future. Whether you like it or not, your shelf life just sitting there working on compressors and fans all day is limited. You can only do that for so long until they figure out a way to replace you with technology. It's just going to happen. I'm sorry. You may not like to hear that, but that's the reality. So you need to learn this IT stuff. And that's whether you're a tech, whether you're in sales, it doesn't matter. I mean, the sales guys and gals, you're going to have to understand at least basic IT concepts, because you're going to be selling to IT buyers now. You're not just going to be selling to facility buyers. And IT buyers want to understand things differently. And maybe we'll do an episode where I talk about all sorts of things like SLAs and roadmaps and product life cycles and all the things that IT folks are used to asking that you'll never really hear from a facility folk. So maybe I'll do an episode on that. If you all want me to, just shoot me an email or leave a comment and be like, yeah, Phil, I want you to do an episode on what IT people want to hear from salespeople. And I could definitely cover that. All right, so number 7, how does this affect the design process? Well, first off, you're going to have more IT involvement. You're going to have a lot more IT involvement, especially if you yourself are immature when it comes to IT skill set. And that's not meant to be a dig on you. That's not meant to be an insult. It's just a reality. You know, I know plenty of areas that I am weak, and I'm openly admit areas that I am weak. And it's important that you be realistic with yourself and not have a huge ego and get yourself in trouble. If you need help from someone, go and get that help. Next up, you're going to have to tie to structured cable and low voltage installers more than you probably do today. You may actually get involved with the electrical subcontractor in the bidding process. You may have to go and do things differently, especially from a new construction perspective. Especially if the infrastructure, the IT asset infrastructure, isn't going to be installed until the building's sealed up, but you're dependent on that IT infrastructure in order to commission your controls. You're going to have to think through all of those things. How does that impact your deployment process? How does that impact your installation process? I mean, you could see the wheels should be turning in your head right now as to all the different things that you are going to be looking at and have to think of as you go to deploy IP-enabled controls. Now, another big one that a lot of these BAS folks aren't thinking about is the impacts to switchgear and IT closet design. So let's say you're using that star pattern, that end run pattern, and it's PoE, and maybe you're using like UPoE from Cisco Catalyst switches, and that's the version of PoE that gives you 60 watts of power per switch port. And let's say you're using that. Well, now if you introduce 1,000 field controllers, that's 1,000 more ports. Divide that by 48. That's almost 20 more switches. I mean, you're talking another rack, or at least another half a rack. And now you're talking about deploying that in IDFs, so information data closets, essentially, where all your switchgear is stored. And what does that mean? What are the ramifications for the access layer? What are the ramifications for the distribution layer of the IT setup? What are the ramifications for the subnet design? What are the ramifications for routing? All these different things that you have to think through. Do you need to set up hardware BBMDs? Do you need to set up software BBMDs? How do you manage all of that? These are all the things that you're going to have to start to think about, which then brings us to subnet and VLAN design. So like I said, if you've never designed a subnet, if you've never laid out VLANs, if you've never done a true network design, then you really need to get comfortable with this. This is going to be really important, especially if you're a designer. But even for specifiers and for salespeople, you want to understand this because it's going to affect your costing. It's going to affect your labor. It's going to affect what RFIs you ask from the contracting tier. If you're maybe a customer and you're doing this at a retrofit, it's going to affect how you deal with your IT group. These are all things that you need to think about. And finally, routing considerations. None of your IP controls are going to work with one another if they can't cross broadcast domains, meaning they can't leave the physical network segment they're in and move to another physical network segment. In order to do that, you need to have a concept called routing. And in order to route, you need to have routes set up, and you need to have an understanding of layer 3 and IP technologies. So you can see all these things. I know I've thrown a ton at you this episode. I know that this episode has probably been one of the more technical episodes I've had, and it's probably overwhelmed quite a few of you. I'm willing to bet. And so I'd encourage you to do a couple things. Here's what I'd encourage you to do. First, I'd encourage you to listen to the episode again and take notes. If something's not familiar to you, if you feel uncomfortable with something, take notes and do a little research. I'll include a lot of past episodes and posts in the show notes, which I'll give you the link to that in just a second. But do some research. I encourage you to go and do some self-study. If you're a student in my IT course, then don't worry. I've got you covered. I talk through all of this stuff in the IT course. So you don't have to worry about that. You're covered. But for the rest of you, I'll give you some links. And I really encourage you to take some notes and go and do some self-study. Next, I encourage you to ask questions. If you're not familiar with something, if something is challenging you, ask for help. Don't try to be bullheaded and push down the path. And finally, the last thing I'm going to leave you with is don't get overwhelmed. Yes, I know that's easy for me to say, but this is stuff a lot of people have learned before. It may seem very confusing to you right now, but you can figure it out, and you will figure it out. If you figured out how to sell, if you figured out how to design BASs, if you figured out how to design HVAC systems and install them, then you have the technical aptitude to figure everything I've discussed in this episode out. All right, with that being said, the show notes are going to be at buildingautomationmonthly.com/83. Once again, that is buildingautomationmonthly.com/83. Feel free to leave any questions about this episode that you have in the comment section. I'll get back to you and answer those. I'm sure you'll have quite a few. And with that, don't underestimate yourself. Believe in yourself. You can learn this stuff. It's really, when you get down to it, it's not that hard. You can figure it out. And I encourage you to do that. I'll be doing a lot more episodes on stuff around IT and IP. And so if you've got any specific questions, leave them in the comment section, and I will talk to you next week. Until then, to your success. Take care.